Common practice has been that when a motor stops working, you may automatically think the whole motor needs to be replaced. However, it may not be the winding half of the motor that failed. It's very possible that there's a problem in its control module. This video will walk you through ways to troubleshoot the motor and modules separately, so you can accurately identify the real problem. You may need to replace only the module, which involves only 2 bolts, making it a faster and easier part change than changing the entire motor. It just makes sense to replace only what needs replacing. First, disconnect power to the unit. Remove the 4 screws that attach the upper blower door. Unplug the harness, which contains the power and signal connectors to the control module. Turn power back on to the unit. Using a voltmeter, check for proper high voltage at the L, G, and N connections at the harness. Voltage should read between 208 and 230. Check low voltage power between C on the white plug and the blue speed tap wire. Confirm that you have 24 volts AC. The motor is communicated through 24 VAC signals to the 1, 2, 3, 4, 5, and C common terminals. Not all taps are programmed. If low voltage is applied to a non-programmed terminal, the motor will not operate, which is normal. Check the published literature of the unit for airflow delivery tables to see which speed taps are programmed. If there are any voltage issues at this point, you'll need to correct them before proceeding to the next step. Now disconnect power. Remove the screw holding the ground wire and replace the screw without the ground wire. Remove the 2 screws from the housing bracket. Grab the housing and partially slide it out far enough so that you can cut the wire tie that's holding the wire harness to the motor mounting leg. Once the housing is free, slide it all the way out and remove it. In order to prevent electric shock and potential damage to equipment, before you move on to the next step, make sure that power has been disconnected for at least 5 minutes due to the dangers of residual electrical charge. At this time, it will become obvious that you have either one of 2 different types of tap select ECM motors. One type has the harness connections built into the motor shell. The other type has an umbilical cord with a connector on the end of a short length of wires. Check to see that the blower wheel spins freely. If this test fails, you do have a defective motor and it needs to be replaced. If the blower wheel does spin freely, it means the motor may be fine and you need to further investigate the module by removing it. Typically, the control module can be removed without removing the motor from the blower assembly. Remove the 2 control module mounting screws and separate the control module from the motor. Disconnect the 3-pin motor connector from the existing control and be careful to depress the latching mechanism before pulling the connector away from the control. Avoid pulling the wires. Depending on which type of tap select ECM motor you have, you may have an additional plug to remove. Check for short to ground. Use an ohm meter to measure the resistance from all 3 of the motor connector pins to the aluminum end plate of the motor. This resistance should be greater than 100,000 ohms. If this test fails and you have less than 100,000 ohms, you have a defective motor and it needs to be replaced. Check the resistance between phase to phase by checking between each of the leads in the 3-pin motor connector. The lead-to-lead resistance across any 2 leads should be less than 20 ohms, and each lead-to-lead resistance should be the same within plus or minus 10%. If this test fails and you have greater than 20 ohms, it means you have a defective motor and it needs to be replaced. If the unit passes all of these tests and the motor still doesn't operate, it's the control module that needs to be replaced, not the entire motor. And it's simple to replace the control module. Like we said earlier, it's just a couple of bolts. To find the appropriate control module replacement part number, reference the unit model number. You could use your Service Tech app to scan the barcode on the unit. Once you have the proper replacement module, connect the 3-wire plug. Make sure the connector is fully seated and latched, and align the power connector and aluminum heatsink with the notches on the motor housing. Insert the previous hex bolts, or utilize the new ones provided in the replacement kit. Start the bolts by turning a few threads on each one, and then fully tighten once they are all in place. Be careful not to over-tighten the bolts. Over-tightening the bolts may result in bearing noise and reduced life of the module. Check to see if the blower wheel spins freely. If not, the new control module is defective. Slide the blower housing back into the unit. Insert the 2 screws to the housing bracket. Insert the screw holding the ground wire. Reconnect the power and signal connector housing and quick connect terminals to the original motor terminal locations. Make sure that the connector of the control is facing sideways or downward to prevent moisture from getting into the connector housing. Otherwise, the motor may have to be rotated. If you used tie wraps, check that they're holding the connector cables properly so that a proper drip loop is maintained. Replace the access panel. Reconnect line voltage to the unit and verify that the blower is operating properly. In summary, when troubleshooting fan motors, don't always assume that it's necessary to replace the entire motor. The problem may simply be the control module. And switching out the module is quick and easy.